Hello everyone. Today myself finishing children. Today I am presenting NID second NID internal to test paper. Sorry, first of all, this is a internal second test paper. First question is write a algorithm for Newton following differential interpolation formula. Move to the next slide. Newton forward differential interpolation formula is this is equation of them where where u is equal to x minus of x naught by h and x of and delta of x naught is equal to nx forward difference at the first number. Algorithm start read and then this is the array which are we read and the value of another array y corresponding to value constant forwarding difference in table for each row each level in I from the 1 to n minus 1 for j from 0 to n minus of n minus I minus of 1. First of all j loop which are going to 0 to that equation and difference table and another array which is initialized by difference table uh, f minus and I minus and minus of difference table j and I minus. Get the value of f for interpolation. Calculate the h is equal to x of I, x of 1 and x of 0. Calculate the y is equal to y minus of y 0 by h. Initialize the result minus of y 0. Compound interpolation for value. For I, another loop which are going to I from 1 to n minus 1 and compute the I terms is equal to I into I minus 1 into u minus of 2. Result is t is equal to t variable which initialized by d into difference table of 0 and v1 is output the interpolation result and end of algorithm. And then there is a def function. That function we divide minus of uh, deflection of x. So another question is write the Python code for Newton divided differential interpolation formula. So for the solution of that, in Python, there is function called divide and def, which have three arguments x, y, and n. And there another variable, array variable, d table is equal to 0 for in a range of n, and another loop in a range of n. For I in range of n, add a table I and 0 is equal to yi. For a j which in the range of 1 comma n, for I in a range of n minus j. Then the array is initialized by this equation which have bought and return the toss array. Then another function which have three arguments and the array finding the length of x array. The table variable which was calling a divide and differ function. A result is stored in 0. And production term is 1. For I of engine 1 is 1 comma n. Production term is equal to this. And the production term. And then the return the result. And the evaluation of uses. Uh, this x value this, y value this, and xp is equal to 7. Interpolation value is Newton divided difference x over y. The third question is prove the sum of Lagrange coefficient is 1. The Lagrange interpolation polynomial is defined as t of x, which has uh, which has go to I to n, which I initialize from 0 to n, and this equation where each Lagrange using polynomial is f of x and f of y is this equation to prove the 0 to n and the li comma x for the any value of x are solving. We construct a Lagrange interpolation for the constant. Then the interpolation for polynomial is p of x is equal to the summation of I to n and the values u li comma x and f comma x of n for this equation. But since this function is a constant, the interpolation must be written the same constant values at r any x. The p of x is equal to 1. P of x is equal to 1. Hence the summation of this equation. So this is the answer. So now our fourth question is obtain a Simon's 3 by 8 rule from general coordination formula. We have know that the general coordination formula over the interpolation is a comma b is this equation where the x naught, xv1, x2 and x naught are equidistant points are weighted for the same for the Simon 3 by 8 rule is equal to n is equal to 3 and 4 points. So x0 is a, x1 is a plus h, x2 is a plus 2h, and x3 is a plus 3h. Mapping of x which belongs to this and to the standard internal equation. The x is equals to x naught plus h where the t is equal to 0 to 3. T1 is equal to 0 t. So the x is equal to x. T1 is equal to 1 and x2 is equal to x1 and t is equal to x is equal to x2. And when t is 3, this x is equal to x3. Now the uh, now the rewriting of f of x of uh, f of uh, x plus ht and integrate this. After integrating, we get this 3 by 8 of f naught plus 3f2 plus 3f2 cos, and then this is equation. This is Simon 3/8 by root. This. So finishing of fourth question. Now fifth question is obtaining Simon's rule from the Newton chord formula. Derive Simon 3 1 by 3 rules using the Newton chord formula close to the formula with n is equal to the Newton chords formula approximate this is an equation hall where x is equal to n, y is equal to b, n plus 1 points. These points are equal and spaced in the with the same size. X is equal to p minus a by 2. So the 3 points are this x is equal to x is equal to 3 by h and this x2 is equal to mapping of x is equal to a plus ht where the t is belong to 0 to 2 and this equation and this uh, the limit is 0 to 2 and f of t dt is belongs to 1 by 3 of this equation and then this is 7 3 by 4 by 3 rule which are this 4 by 3 is equal to f of x plus 4 f of brackets a plus b by 2 and this plus f of h. Now our sixth question is solve this dy dx is equal to 1 plus x square and 0 of x is equal to find the x y is equal to 1 in a step of 0.5 with the Euler's modifier method. So given that d by dx is 1 plus x square is equal and y now y0 is equal to 1. Find the y1 using Euler's modifying method with the step size h is equal to 0.5. Their equation. So the equation which are formed by formula is this, and this is y, and the next sequence, the next step of y of n is equal to y of n plus h plus f into f bracket of x of n plus y of n and f of y x comma y is equal to 1 plus x square and the f of x naught comma y naught plus 1 plus 0 is equal to 1, and this is equation, and and the value of y1 is equal to 1.5 and the value of the f of x2 is equal to y2 is equal to 1.25 and x2 value is equal to 1.28 something. Now the x is equal to 0.5 and y2 is equal to 1.28. The summation of them is equal to 1.25 and y of n is equal to y2 plus h of f of x comma y, and this is equal, the equation is equal to something by the answer of them 2. At the end y of 2 is equal to, answer is 2 point something. Our last question is find the value of lambda of room of limit 0 to 1 d of x using the 3 points Gaussian coordination formula. Gaussian coordination formula is for the interval from -1 to 1, so we have transformed the interval 0 to 1. This is equation of to standard form. So the -1 to 1 f of x plus 1 plus s by 2 into 1 by s of dx. So now limit goes to 0 to 1 plus 1 by 1 plus x square dx is equal to, limit goes to -1 to 1 plus 1 by 1 plus 1 into this dt. This is v. The limit goes to -1 to 1 of y of t dt, where the y of t is equal to 1 by into of x 1 by 1 plus this of 3 points the Gaussian coordination formula and the width. For this, are we computing it at the h of t? For the t is equal to minus 0.7746, so x is equal to 1 plus 0.7746. So this is equation answer. Or for the t is equal to 0, the x is equal to 0.4, and for the t is equal to 0.7 something, so x is equal to nearly 0.2796. Applying Gaussian coordination formula, so the answer is overall 0.7352. This is the end of second internal question answer. Thank you.